Okay, last hydrolysis, I lied about how many videos I made. I kind of screwed up a couple times, had to go back, whatever. Last hydrolysis for now on enamines. Same concepts as before. Not gonna really change much. Let's go ahead. Pair there. There's our enamine. Nitrogen one away from a carbon-carbon double bond. This is hydrolysis, so I know I need water. And because it's an enamine, I should have mildly acidic conditions. What makes a good leaving group? Positive charge. What gets rid of a leaving group? Usually reforming a double bond, okay? And identify what our product needs. Meaning we should have a carbonyl, and with enamines, what kind of amine should we expect? Secondary. Enamines are secondary. Amines are NH3 and primary, okay? Amines are secondary. So we should expect a secondary amine up there, and then we should expect a carbonyl down there. Let's go ahead and get started with this, okay? The first step in this is gonna be a little funky, but it's gonna look, what's the word? It's like an ammonium ion. We basically make imine and we do the same thing as we did before. It's not technically imine, but it's really close. It's imine with like a plus charge. It actually makes it easier. So to make an enamine hydrolysis reaction, make sure you watch the last video. Almost all of it's gonna be the same. Our first step is we're really gonna make an imine or ammonium ion, basically the same thing, and then do the same thing, and then do what we did in the last video, which was pretty much what we did in the first video, okay? Okay, I need to make an ammonium, an imine. I need a nitrogen carbon double bond, and this carbon double bond needs to go away. How am I going to do that? I need to form a double bond here, and I need these electrons to go away, okay? So I'm still at 4 bonds there. If I add a double bond, nothing's changed there. I need to add something down here. It's going to protonate. It's it's nucleophilic attack, but it's really proton. I don't know. Reform your nitrogen carbon double bond and take the other double bond that you don't want, give it a hydrogen, it'll disappear. I'm lazy with that step. I should draw a bond there. Okay, so I basically went from enamine to, it's almost imine, it's ammonium ion. Okay. That step, kind of on its own, but if we can make an enamine and imine, we're pretty much almost done. I have water here that can attack. I'm already protonated in that carbonyl position. It's already activated. So let's go nitrogen there, 1 carbon down there, and then my water. I have a charge in my species because of proton excess. What do? Take it off. I can use water for that. And get that. Okay. 1, 2, 3, 4 carbons. 1, 2, 3, 4 carbons. Just shaped a little weird. Cool. I want an oxygen carbon double bond. I want this to leave. Let's protonate it first. Okay, we still have a lone pair there on nitrogen, which you can protonate with. I would use H3O with that. and I should get this. Now I have a really good leaving group. Form the double bond, leaving group is kicked off, and I'm left with right, 2 carbons there, 1, 2, 1, 2. I didn't draw it the clearest, but take your time on that if it doesn't make sense right now. Rewind. Maybe tilt your head to the right a little bit. And then we also had our secondary amine produced. Crazy. It's like we're going in the reverse direction. Which again, your book does not show. Not like at all, which sucks, but it's what SI is for, I guess. Not really, but it is now. I would take a proton off and boom, I'm at my starting materials on how to form an enamine, or I can take my enamine and go all the way back to my I don't know the technical name for this, aldehyde. Well, like the practical name for it, should. And then our secondary amine. So hopefully you see a lot of the same steps going on in hydrolysis of acetyls, amines, and enamines. Positive charge with leaving groups. What do my products want? A lot of the same steps are going to repeat. Wolff-Kishner and nitriles next.